Information Center in Golden, Colorado. I'm Lynn Kimbrough, and this is the FEMA Podcast, taking you to the National Earthquake Information Center in Golden, Colorado. This is a 24/7 operation. Scientists are here scanning the world to both monitor and collect information about earthquakes. If we only had one word to describe what is done here, it would be data. While you carry a small computer in your pocket that can do amazing things, imagine the power behind a large room filled floor to ceiling with computers.
So what we're looking at here is a big rack of computers. The noise is coming from the AC that goes through these computers. They get very hot. And through these computers, these run our real-time system that analyzes the data, and also, just as importantly, it collects the data and distributes the data.
Paul Earle is the director of 24/7 operations at the United States Geological Survey's National Earthquake Information Center.
This is the media room. This is the actual screens that they're looking at. This is a map of the Earth. When a new earthquake comes up, it pops up on the screen. The red line shows converge where the earthquake is and go out to where all the stations are around the world. I
asked him what a typical day might look like.
A typical day, there's nothing super exciting going on. And that's the typical day. But on a non-typical day, it can get very exciting around here. You can get a large event coming in, and when all hands are on deck, and you're making phone calls to get more hands in to help out.
What are the missions that you have here?
Our core mission at the USGS National Earthquake Information Center is to reduce the societal impact of earthquakes through monitoring, research, and education.
Sounds kind of simple, but I know that it isn't.
There's a lot behind that. Even coming up with the mission statement is difficult.
When we talk about monitoring, it is not just here in the United States. You are all over the world.
Yes, our mission is worldwide. So we run a 24/7 facility here, and we monitor earthquakes all over the world. However, we do concentrate in the U.S. So we locate smaller earthquakes in the United States, and we're also
Most of us don't think about earthquakes every day, so you might be surprised at how common earthquakes actually are.
One misconception that people have is that earthquakes are a rare event. They happen all the time. They happen all over the world. They're not always felt. Every day you generally have a magnitude 5 or larger earthquake somewhere in the world. And each time you go down in an order of magnitude, you have 10 times that many earthquakes. So we'll have, about 10 magnitude 4s, 10 or more magnitude 4s, 100 magnitude 3s, 1,000 magnitude 2s. We have plenty to keep us busy here.
In fact, as Paul was showing me one of the monitors, I was surprised to see a magnitude 6 earthquake listed in New Zealand. Well, that seemed pretty big to me, but Paul explained why no one was getting too excited about it.
The nearest place is New Zealand, but it actually is far out to sea. So this is about 500 miles from the populated New Zealand. But these earthquakes happen every day. They're interesting scientifically. They tell us about tectonics. They tell us about how earthquakes cluster, how earthquakes happen, and they also give us practice for when one occurs that's going to affect a populated region.
When you gather the information that you're watching, all of the monitoring that you do, and something's happening, what then in turn do you do with that information?
There's a whole kind of flow of events that happen after we have a large earthquake, and that begins with first determining where that earthquake is and how big it is. And that's done not only by us, but by a number of seismic networks in the United States. And in different regions like California, Oregon, these networks will submit a solution, and that will come to us, and that will go on the USGS website. So this is a very collaborative effort to monitor earthquakes within the U.S. And we also, so as the national center, we back up these regional centers within the U.S. So, for example, if you look at Utah, they have a network in Utah that is that monitors the threat from the faults in that area. And if there was a large earthquake, they may be taken out. But we have data feeds that come from them directly into us, and then we can back up Utah if it's needed.
Once an earthquake has happened, you're collecting this information. What do people do with the information that you can provide back? I know that the media often enjoys reporting about the number, the magnitude.
Exactly, and that initial stage is just to get that magnitude and location out. However, that's not really what the emergency responders want. And we have a whole suite of products that follow on beyond that initial magnitude and epicenter. Kind of one of the upstream products that's very useful is a product called Shake Map, and this is a map that has the estimated or observed shaking from an earthquake on top of it, and you can use that map to determine the areas that have shaken more or less, and the amount of shaking that different areas will experience. And this is important because that's what emergency responders are interested in, more so than just a number and a location. They want to know what that did. Beyond that, we have products that actually estimate the potential impact of the earthquake. So, how many fatalities are likely to have occurred because of this earthquake, and how much economic damage is likely to occur from this earthquake. And that's a project called Pager, and it dovetails very well with FEMA's HAZUS estimates. And as a matter of fact, there was a lot of collaboration in the development of Pager, especially the alert levels with FEMA in the development of that, to make sure that it was in line with the responsibilities that FEMA has. Beyond that now, the Shake Map actually feeds into FEMA's HAZUS programs. And the HAZUS program, for those that don't know, are programs that estimate the effects from an earthquake, the potential that goes beyond what the USGS estimates do, that come out rapidly, and estimates a lot more factors that affects from the earthquake than just fatalities and economic loss like ours do. So it's a very good partnership because our estimate comes out very early and then informs the FEMA estimates, which gives them more information that the emergency responders need.
There is a lot of work to be done when a significant earthquake occurs. It requires Paul and his colleagues to go into action.
So after an earthquake, we don't only participate in kind of the immediate response stage, but the NAIC and the broader USGS helps out and overlap with kind of the recovery phase. An earthquake just doesn't happen and then it's over. It's generally a sequence of events with a main shock and a series of aftershocks. And to help the public and to understand the potential threat of that earthquake, we will send out a team that does aerial reconnaissance and understands the extent of the fault, understands if it's a new fault, helps us understand the orientation and the potential threat of that fault. We will put down GPS instruments. We will put down more seismometers so we can better understand what's going on and may help us understand the immediate and midterm threat.
In any kind of an event now, really anywhere in the world, there's another dynamic at play, and that's social media. And And are you part of information that might be gleaned from social media as well to plug into what's happening?
Yeah, we were actually pretty early adopters of social media at the National Earthquake Information Center, and I was involved in a project that used Twitter data actually not to broadcast. I think most people started looking at this as a broadcast mechanism, but we were looking at it as a data collection instrument. And so we went out and developed a system completely independent of seismic data. So no seismographs used in this, that we could just look at Twitter data and determine when and roughly where an earthquake occurred, just by looking for an increase in the use of the word earthquake in various languages.
That's amazing.
It was one of those, it actually started because somebody asked why we weren't doing it, or why we weren't looking into this, and I thought, that's not going to work. So I looked into it, and it worked. And it works amazingly well, and we can detect earthquakes in regions where we don't have seismometers that are small, and then we can also glean information from what people are saying about that earthquake quickly.
For people in earthquake-prone areas, perhaps the biggest question is about the ability to get an early warning that an earthquake is about to occur.
There's a lot of work being done by the USGS in collaboration with FEMA to make progress down that road. Prediction is kind of a word we don't use very much, but what we do use is a word forecast, kind of like a weather forecast. So what the USGS does is they produce a map of potential earthquake hazards, so that shows in different regions if you would expect a certain level of shaking in a certain amount of time. So those regions are going to be more hazardous regions. You can identify regions that are more hazardous, that may need a stronger building code. So building codes are based on those. So FEMA can look at those and know the regions that are more vulnerable for planning purposes. There's other products like scenario planning, where you can look at a fault that might rupture in the future, and then so we can do the science end of that and produce these maps of estimated shaking from an event like that, and hand that to FEMA, and they can figure out what the potential human effects are from an earthquake like that. We've developed over 800 of these scenarios, which we've shared with FEMA and other federal agencies. The other kind of line of research and development that's going on that people sometimes think of when the P word is mentioned is earthquake early warning, which is not actually prediction. Earthquake early warning is a alert that can go out before shaking is received, but after the earthquake actually happened. So when an earthquake happens, the shaking propagates out from where that earthquake originated, the hypocenter of that earthquake, and then travels at a speed that is slower than the speed that you can communicate that earthquake happened. So you can actually communicate outside the front of that shaking area and alert people that shaking is coming. And there's a project going on right now on the West Coast that includes Oregon and Washington and California, called Shake Alert, and that's what this project is doing, is earthquake early warning.
That's really amazing. You mentioned California, Oregon coast. I think people in the United States broadly understand that is earthquake-prone country. Does it surprise you that there are still people who are unaware that we have some other areas in this nation just as prone to an earthquake?
I think that absolutely. I mean, it doesn't surprise me that people don't know. We need to continue to educate. I think about earthquakes every day, so sometimes it's hard for me to put myself in somebody else's position that has different worries and priorities, but we need to do a better job of educating people that it can happen in other areas. And I think one important point to emphasize with people is that the to prepare for an earthquake, can do similar things that you need to do for other hazards. Storing water can be useful if you're in a area that has tornadoes. So a lot of the earthquake preparedness can prepare you for other hazards that may be more likely in your area. So it's a good idea to think broader when you're preparing for hazards. But an earthquake can happen just about anywhere in the United States.
Are there some areas that you watch a little more closely? And I'm thinking the Wasatch Front and the New Madrid Fault.
There are certainly areas that are more prone to earthquakes, and those are mapped in our hazard maps, and we watch them. I hesitate to say we watch one area more closely than another because we watch the whole Earth all the time. However, we do have more seismic sensors in areas that are more hazardous or more likely to have an earthquake. But we are always on and we are always vigilant. People ask us, what we're stepping up after an earthquake. We keep doing what we always do. We watch for earthquakes. We've got a system set up that we can continue to be effective all the time, and we follow those procedures.
How long have you been doing this?
I've been here for close to 19 years now. I've got a PhD in seismology from University of San Diego, and then I did some postdocs, and I used to study deep earth structure. So what does a core mantle boundary look like, and how fast do seismic waves travel deep in the earth? And that's very applicable to what we do here, because that's the basic physics that goes into detecting the earthquakes and interpreting what happened during an earthquake.
And when you think about all the different things that the National Earthquake Information Center does, your different missions, what do you like the best? What's the best part about your job?
The best part about my job, which I personally like about my job, is we are watching everywhere in the world, and we are trying to help everybody in the world. And when there's an earthquake somewhere, we pitch in and we help and we inform what's going on. And it might be somebody of a place that you've never heard about, and you learn about this place, and you learn how you can help, and you provide this information, and you can feel like you're being a part of the solution.
That you've made a difference because you did, and you continue to do that. So thank you for that. Is there something that maybe I wouldn't know to ask, or that people tend not to think of? What else would you like people to know?
There's some resources on the web. If you go to our website at earthquake.usgs.gov, after an earthquake or when there's not an earthquake, there's a lot of information there on current earthquakes, all our products like the Shake Map and the Pager and other products that we have that I didn't mention, such as landslide potential after an earthquake, liquefaction potential after an earthquake. Those are all automatically posted for large earthquakes. Aftershocks, potential for aftershocks are also posted on this website. So there's a lot of content and useful information, not only for emergency responders at FEMA, but the general public on our website.
We welcome your comments and suggestions on this and future episodes. Help us improve the podcast by rating us and leaving a comment. If you have ideas for future topics, send us an email at FEMA-podcast@fema.dhs.gov. And if you would like to learn more about this episode or other topics, visit FEMA.gov/podcast.